we did a long tutorial and we learned so many things. We learned how to set up Kafka, how to set up Postgres, and how to configure those, how to set up a Debezium, how to configure source connectors, how to configure sync connectors, how to sync data from source to destination, and also how to maintain those, how to make sure connectors running, how to check health endpoints, and how to restart in case of failures. We learned so many things. So now we can do this perfect production ready enterprise level CDC configuration by looking at this tutorial. Hello, how are you guys doing? Today we are doing a very important video. Yeah, it's a little bit longer than usual video, but stay with me, you will never regret. So after I released my first video about database events and how to handle those, and about the CDC and CDC based replication, most of you asked, can we do this practically? So I knew doing this practically is like tedious task because it's a little complicated. I have to set up so many stacks to do this, because all my examples I'm trying to do industry standard and close to enterprise level. So I looked everywhere, YouTube channels and even Udemy and other course platforms, to see is there anywhere something available so I can refer that to you, how to set up this CDC based environment on the enterprise level application. But unfortunately I couldn't find any. There were so many tutorials. Most tutorials are based on Dockers. That means they like spin up a bunch of Dockers for the Postgres, Kafka and CDC, Debezium and everything, and then they demonstrate that. Those videos are not wrong, because intention of those videos to show the CDC and how CDC work. The intentions of those videos are not how to set up that in an enterprise level. But I want to show you how to set up in an enterprise level application, because in enterprise level application we don't run Docker, Kafka on a Dockers or a database on Dockers, right? So I wanted to do something really close to enterprise level. So to fill that gap, and since most of you asked how to do that, I'm going to do that video today. Like all my other videos, this also will be very close to real world enterprise application. That means you can take this setup and you can deploy this setup on your real enterprise application project. But that being said, I need to admit I am violating some best practices as well. So you need to be very careful, you need to be cautious when you apply into your real project. That means, for example, I'm using same subnet to Kafka and database and Debezium and everything. And also I am using very simple password for master password of the database, and also I am using the master account for Debezium sync. And also I'm using wider open security groups. I'm doing that because I know this video will be longer than our usual videos. So I don't want to spend more time to create more security groups and more password roles and more subnets, because I know I'm not focusing on those this video. This video is totally focused on the CDC. But before that, make sure you share this video with your friends and who's interested to learn this type of thing. And also make sure you subscribe to my channel, because so many more interesting things to come. First, we need to create few stacks for this one. I'm using Kafka, MSK, managed service for Kafka on AWS, and I'm using Postgres as a source database, and I'm using MySQL as a destination database, right? So now MSK, Kafka, it's an enterprise grade, Postgres, Aurora Postgres is enterprise grade, and MySQL is enterprise grade. And to make it more enterprise ready, I'm using Postgres server with the read replica also. So that means with a high availability real enterprise database provisioning. So I'm going to provision all those on AWS, and then I'm going to create a jump host on AWS EC2 instance, so that we can log into that EC2 instance and get these things done. And for the Debezium, I'm running those on a Docker with a Docker Compose. I already pre-prepared my Docker files, so because I don't want to write in front of you and waste more time, but I'm going to share these Docker files on my GitHub. So if you need, if you're interested, if you replicate in this, you can use those files without any issue. Right, first let's go and spin up our EC2 instance. So this is the VPC we are going to use for our demonstration. Keep in mind our focus is about CDC but not about the VPC. So I'm not following best practices, tighten securities, firewalls, network routing and anything. This is the very basic VPC setup. So I have two subnets to high availability, and those subnets directly open to internet gateway because I want to access these hosts from internet. But keep in mind, when in your real project, you don't open your traffic to internet like this, and so make sure you adjust this according to your situation. So I'm going to launch a new instance. Though this name as a jump host, this is the host I'm going to use to run Kafdrop and Debezium and everything. So this will be Amazon Linux, and I'm going to use this architecture. I'm fine with this, but I'm going to use little high-end EC2, probably T3X large, so then it will be faster work. And key pair, I'm going to create a new key pair, and I'm going to create the key pair, and I downloaded it, CDC cluster, and I'm going to create this in the CDC subnet B. I'm fine with it. And auto sign public IP, I'm going to enable it because I'm going to connect when it come from internet. And for the security group, I'm going to use CDC cluster security group, and then I'm going to launch this. So yes, I'm in. Why we need to install Docker and Docker Compose? Because we are going to run Debezium and Kafdrop and Kafka Connect UIs as Dockers. So let's install Docker to this one. Docker to start automatically. So now I need to install Docker Compose. It sounds good. So now I need to set the permissions, and let's see whether we have Docker Compose installed. So now we can go ahead. Okay, so now we need a database. So for that, we are going to spin up a PostgreSQL database. For this example, I'm going to use a PostgreSQL as a source database, and that also I'm going to use a AWS RDS PostgreSQL as a source database, because I want this example close enough to real world situation. In real world, we don't provision database manually on EC2 instances, because then we need to manage everything. But since the managed service provided with AWS, we most of the time go with the RDS based PostgreSQL or a MySQL or whatever you're using. In the PostgreSQL, I'm using Aurora PostgreSQL, because you can see here there's other option called PostgreSQL. If you choose that, the option is very different, because this is kind of a provision mode. But if your workload is not predictable, it's always better to use the Aurora PostgreSQL. Then you can use Aurora serverless or Aurora provision. So whatever you can choose. But here I'm not using serverless. I'm going to use the Aurora provision mode. And database version, I'm going to use the 15. And for this one, I'm choosing dev test. It's nothing but just a configuration and the replications, but I can control manually. For this, I'm going to use a dev test. And for the database, I'm going to use Cosmos PG database, and username like this, but password I'm going to change. I'm going to use very simple password here, but don't do this in the production. In the production, you need to have a strong password. And then IOPS, I'm going to use the Aurora standard. And for this one, I'm going to use very simple database. I'm going to go with T4G medium. It's a 2 CPUs and 4 GB memory as this one. But when it comes to Graviton instance, it's like cheaper than other instances. So I'm going to ask to create a replica, and I'm not creating any endpoint, and I'm going to use the CDC cluster VPC. And for that, I'm going to use the CDC subnet group. You can see 2 subnets in 2 availability zones. For this one, I'm creating a public access enable, but when you do that, don't do it. Don't create a public access to your database directly. We have a different security mechanism we can follow. For the security group, I'm using cluster security group, CDC cluster security group. There I open the required ports to connect to Postgres, and I don't need this one. Port I'm not going to change. Let me to change the port just for sake of security. So then I don't need this. And for the cluster configuration, I'm going to use the default one. CDC is not enabled by default. When you use this default configuration, you cannot get CDC to work. To enable the CDC, you have to do the special configuration. I'm going to create the cluster like this and show you how to enable the CDC on RDS Postgres. And that's it. Failover preference, I'm going to use a tier 2. And backup, I don't need to keep. And I think that's it pretty much. I'm not worrying about this maintenance and anything because I'm going to delete this as soon as we recorded this. So I think because of it's enabled to outside, it worrying about this weak password. Otherwise usually they don't worry this about much. Okay, let's see what it says now. So now it says cannot create publicly available instance. The specific VPC does not support DNS resolution, DNS host name, or both. Okay. So let's go edit VPC settings, enable DNS host name, save. It should good to go now. So now you can see it's being created. So now it has a reader and writer instance separately. You can see now both goes as a reader, but when it provision, one is converted to writer, another one is getting created to reader. So now we have a database. Now database will be emit event. So I need Kafka to capture these events. Here I'm going to use the AWS MSK because as I explained, this example should close as much as possible to the real world situation. Before I create a cluster, I'm going to create a cluster configuration. I can do this in either way. That means I can create the cluster first and then go to configuration and create a revision for the configuration the way I want. Or if I know exactly what the configuration I want, I can by default create that configuration and then I can create the cluster using that configuration. Either way is fine. I'm going to go to create the configuration first because I need two broker cluster because this is the example. So I'm going to create the two brokers because in the MSK you at least need to create two brokers. So I'm going to say CDC, right? So this is optional and these are the configurations. So here I want to enable this topic create, enable this false. By default auto topic creation is disabled. I need to make sure that is enabled because otherwise I need to create the topics which required for the tables. I don't want to do that. When I create the table, I want my CDC setup to automatically create the topics. So how we do in a production usually, we create this as a true and then we run our CDC setup and everything. Once setup complete, we come back here and set this to false. Then we can make sure no one creating the topic unnecessarily. And default replication factor I need to set to 2 because I only have 2 brokers. I'm going to create 2 brokers. And minimum in sync replicas I'm going to create as a 1 because since I have 2 brokers, I'm going to create this as a 1. So this is I'm fine with this. This is also fine. And minimum partition is 1. It's also fine. Replica fetches also I'm going to set to 1. And these numbers I'm not much worrying about. So redirection enable I want to set to true. And also I need to add new one called delete topic enable equal true. So I'm going to enable to topic create and delete both. So then it's easy if in case if we need to create or delete some topics. Okay. So let's create this one. So now I have the configuration. So now I go to cluster, create cluster. Here I'm going to choose custom create because I want to have the full control on the creation process. Cluster MSK. And I'm not using the serverless. I'm going to use the provision because most of the time in production you may use the provision. And the brokers, I need to use kind of M7. I'm going with the M7 G. It's a Graviton again. It's cheap. And I can go with something simple though. I go with the T3 small because I need the very simple Kafka cluster. And broker per zone is 2. Number of zone is 2. and 1 broker per zone, so that means altogether 2 brokers. I don't need this much of capacity. I just create 100 GB, right? ESBS only, American default configuration, custom configuration, because we create the configuration, and we can say custom config revision 1, right? So I'm going to click next, and I'm going to go to this CDC cluster VPC here. So it's A, and I think I don't have anything on the C. Yeah, I didn't create. Other one is in the B, so this is my subnet. Public access off is by default. If you want, you can create a public access, but I don't see I need a public access for this one, so I'm not going to create this. And I'm going to add my security group. Okay, so that's I'm good. Now click next, and I'm going to enable unauthenticated access for now. It's okay to have IAM authentication as well, but I'm going to enable unauthenticated access, and I'm going to enable the plain text as well, and I go with the basic monitoring. I mean, if you do the real production project, so you probably need to consider to enable the log deliveries to CloudWatch and everything, but for this one I'm not. So now I have everything. Just click create cluster. So now usually it take 15 to 20 minutes to create the cluster, and let's see, go back and see what happened to our database. Okay, database is being created, and now you can see one is a writer instance, other one is a reader instance. And if I click on the writer instance, I can see I should have a publicly available DNS for this one. Yeah, you can see the endpoint. So this is the port, right? So let's go and see whether I can connect to this one. So I'm going to create server group, and then I'm going to create a server, and the connection is this. So port is 5481, and the password is, it's a very simple password I use, and I'm going to save the password. Let's see whether it can connect. I think yes, it's connected. So I'm going to create a database here called Cosmos and known as Postgres. These are not best practices. You probably need to create your own user, super user, and then set that user as an owner to your databases. But our goal is to demonstrate the CDC. So this is what you need to understand. So if you go here and if you run a query tool, right, if you say show one level, so you might see this goes as a replica, right? So that means CDC is not enabled. If the CDC is properly enabled, you will see this as a logical, right? So if you have this seen as a logical only, you can work as a CDC, right? So that is what you need to keep in mind. Now, by default, as I shown you, by default, Postgres doesn't support CDC. That means when the data change, it doesn't emit any event. So therefore, we need to manually enable CDC to our database. So that means after that, it will be emitting events. So then we can configure the Debezium to capture the event and send to Kafka. So let's see how we can enable CDC on Postgres on RDS Aurora database. So what you need to do is, so you can see configurations. So here you can see cluster configuration is this one, right? So what I need is, I cannot update this group default one, so I'm going to create a parameter group here, right? So I'm going to create a parameter group, and this is Postgres, this is PostgreSQL, and parameter group is 15, right? And this is not DB parameter, this is a cluster parameter group. Okay, so we're going to create this. Okay, this is it's required. Okay, let's go with this one, and now I go here and I'm going to go to edit mode, and I'm going to look for something called RDS dot logical replication, right? So you can this one. So you can see here the value is set as a 0, right? So this has to be 1. So this is what we call as a CDC enable. So now you can see we update the parameter group, and we need to select the cluster and modify, and we go back here, we set cluster parameter group to the created one, CDC enable one, and click continue. It's asking apply immediately, modify. And now what we need to do is we need to restart the cluster in order to take this effect. So you need to stop this temporarily, and after stop you need to start it. And meantime, let's go back here, and what happened to our clusters, it's still being created. So now our right instance is available. Let's go and see our level again. So probably this go disconnect. Yeah, it's going to reconnect. Now you can see it comes as a logical. So one level is logical mean now it's ready to publish CDC event. If it is a replica, then CDC is disabled. If it is logical, then CDC is enabled. So now we can move to the next step. So now this is RDS. Maybe your database is not RDS, maybe your manual provision database, or maybe you have a database run on EC2 instance, and so and so. These configurations are same, almost same. Therefore, you just Google. So you can always refer official documentation. So you can go and see how you can enable CDC for your database version if you are not using the RDS. And also if the source database is a MySQL or Oracle or a DocumentDB or a MongoDB, any source database you can use, though I am demonstrating with the PostgreSQL. Okay, now we have set up all the tools and databases and everything. Now let's get started to configure all those things together to get this work, right? For this one, we need few dockers to run. For that, I'm going to use a Docker Compose. What are the dockers we need? First, we need the Debezium connector. What the Debezium connector does is, it read to the database, take the events and publish to Kafka. For that, we are going to use the Debezium Kafka Connect. But Debezium Kafka Connect doesn't have any UI. Why? Because it's just an engine with the REST APIs. So you need to call to REST endpoints to create your API, create your connectors. So that is not a very easy way. Therefore, I'm going to use Kafka Connect UI for that one. So now we need the Debezium Connect, which is the real Debezium, and then Kafka Connect UI. And then we need the Kafdrop. We are going to use the Kafdrop to see the topics and the partition and the lags of the Kafka, right? So that is the easy way to monitor the Kafka. And later on, we are going to encode this message with the Auro and put it into the schema registry. For that phase, we are going to need the schema registry as well. Then only this become a real complete enterprise project. Okay, so let's get going. So I connect to this server. So now I'm going to create a directory called CDC, and I'm going to move into this directory. Okay. For here, I'm going to create a Docker Compose file. Don't worry, I'm going to share this on my GitHub, so you can take this. Let me to create this one for you now. So I'm going to create Docker Compose.yml. So before I use this, let me to walk you through my Docker Compose file. So here you can see first image is the Kafdrop. For that, I'm going to use this image, and here I'm configuring Kafka brokers to my Kafdrop. So I can get the Kafka brokers from my Kafka cluster. So this is my CDC cluster MSKV what we created, and here I have the brokers, right? I can copy and paste the brokers here, and I have two brokers, and then it's going to listen on a port 9000. And then this is the Debezium connector. So this is a real Debezium thing which is taking the events and publishing into Kafka. For this one, I'm going to use a Docker file to build this image. The reason for this is from Debezium 2.0, they stopped natively support for the confirmed schema registry. But I need to use the confirmed schema registry. What I'm doing here, I'm using a separate Docker file. So there, I'm taking the Debezium image. So you can see it is coming from the Debezium Connect image. So right, you can see it here. And then I'm going to plugin directory. I'm download this bunch of Confluent Kafka schema registry libraries, and then I'm starting this one. So now I get the Debezium 2.0, which is the latest version, and also I get the Confluent support. Other than that, you can go with a different schema registry or something like that without doing this massive work. But this way it's very easy. So I can keep separate my Debezium connector from my original Docker Compose file. right? So here I'm downloading all the libraries, but I need to convert my message to euro and store in a schema registry. Okay, so now after that I'm going to use this one port 8083, and I need to set up 3 base configuration: storage topic and the offset storage topic and the status storage topic. For this one I'm creating these topics name, and then I have again configure the same Kafka broker URLs, and then I need the UI, right? I explained, because this one is just a REST API, it doesn't have any graphical user interface. So here I'm using the UI. For the UI I'm going to use this land loop Kafka Connect UI, and that's going to listen on the port 8083. So this is to point to the REST API what I'm using. So this natively support on the port 8000. Okay, so now I'm ready for this one. I'm going to take this. So now I don't have any file. I'm going to create docker compose.yml, and here I'm going to paste this file, right? So I need the now docker file as well, right? Did I make any mistake? No, right? Correct. And now I need my docker file as well. I need a docker file. Guys, don't worry, everything will available on my GitHub. So I'm on insert mode, I paste it, right? So I'm good. So now it's ready. I need to make sure I pass the build operator to build this one. So I'm going to use sudo docker compose -f. I don't need, since I'm using the default file, but I'm going to anyway pass this up -- build, right? So now it will build my containers and up. Now ideally I should be able to connect to my Kafdrop and Kafka Connect UI. Let's see. I'm going to use 9000 port. Yeah, I have the Kafdrop. So this is my Kafka cluster, and you can see we created 3 topics here in our configuration. So these 3 topics are created, right? Let's see our Kafka Connect UI. I'm going to duplicate this and use port 8000, right? So now I have a Kafka Connect UI as well. So this is kind of optional. If you don't need the UI for your Debezium, you don't need this one. And then I'm going to duplicate this, and I'm going to use port 8084 as I remember. I think 8083. Yeah, so this is my real Debezium. It doesn't have any connectors now, so it won't show you anything, right? So now we have the setup. Okay, so now we can create our first connector. The first connector I'm going to create without a schema registry, so then I can show you how this works without a schema registry, right? For before that, I need to create a database. I need to create a table on my database, so then I can use that. For that, let's go to pgadmin, and here I'm going to create and this is the table I want to create, employees table, and it just have a few names like a name, ID and everything. So ID is auto increment field, so it's easy for us, and then name and the city, and the primary key is ID, right? So this is it, and I create this table. And let's go here and tables, and I can see my table, right? So right now I don't have any records. So let's create the first connector. I'm going to create a Postgres connector. So here this is just a connector name, and this is the class we are using. If you're using Debezium, this will be this one, but if you're using the Confluent Connect, the class would be different. Here this is the database name, and I'm going to use the user as Postgres. And the sort name is kind of zone it creating for this connection, and then this is the Kafka. So this tells create this database and go and put this message on the Kafka. So here we need to give the history topic. So this can be anything you want. The history topic mean, so this is the topic, it keep the offset about the last LSN, last sync number, and all those metadata stores in this history topic. If you want to kind of reset the sync again, you need to delete or change this history topic. Then it start from the beginning, because Debezium doesn't aware about anything about the history about this particular table, right? Particular connector. And then you have server name, and this is my database server, and here you can see that's what I said, like I'm using the basic like fundamentally wrong. I'm using very simple password, and also I'm using a Postgres user. As I said before, you shouldn't do this, and you can create a separate user for the CDC sync, and then you are creating what is the table you want to sync, and then this is your database name, and that's it. Initial mean I need to create if there are any records on my database, it will sync to Kafka, right? So that's it. I'm going to create this one. Good. Just because of I'm creating this, nothing changed. So now what I'm going to do is I'm going to create a record on my database, right? So I'm going to remove the ID because ID is auto generated. I don't need this, right? Okay, so here I'm going to use Krish from Colombo. Okay, I'm going to create that record. So you should see here it detect these records and sync. See, you can see it is syncing to my Kafka. So if I go here, I should see the new topic. You can see cosmosdb.public.employees. So these values, this cosmosdb is coming from the configuration, connector configuration we given here, right? So you can see here we given the cosmosdb as a topic prefix. So that is the one it picked here. So now if you go to this one, I can see one message, right? So if I read this message, you can see schema is embedded to this one, right? So you can see it tells what are my table fields, right? So this is the ID, what the data type is optional, right? So what is the primary key fields and everything, right? It tells everything about my stats, and then at the end it tells what is my data, right? So before is null because there is no before because this is insert, and then ID is 1, Krish is Colombo, right? So you can see OP is C. OP is C's important thing, right? What the OP mean? Operation. It will be C if it is a create, it will be U if it is a update, it will be D if it is a delete, and it will be R if it is creating an initial snapshot. Okay, so now if I do okay, I think we should move to the schema registry because this is like kind of a little obsolete thing, right? So to move to schema registry, what we need is we need to create the schema registry also in our Docker Compose, right? So I'm going to, okay, you need to understand before we go there, what is the disadvantage of this? Let's say you are syncing a 10,000 records. This schema get duplicated 10,000 times is unnecessary because usually your table doesn't change, right? So in that case, it's not necessary. So what we are going to do is now we are going to use a schema registry where we have a schema registry to keep the schema. So that schema registry will hold the schema and we just share the payloads, right? So now what I'm going to do is I'm going to stop this and I'm going to add schema registry Docker into my Docker Compose file. Okay, cool. I'm going to use Docker Compose YAML. So now I should have this in the same level. I'm going to use a schema registry and I'm going to paste this. So now what I just did, I get the schema registry Docker also to my Docker Compose file. So let's run this one. So do Docker. So now it will get a new image, right? It's a schema registry. Okay. So schema registry is supposed to start on 8081. So let's duplicate this and see 8081. You need to make sure you open all these ports. Now schema registry also running, right? So what I need to do is now I need to go to my connector and I need to add schema registry properties here, right? So then only, oops, I can add it here. Let's add at the end so then you can understand easily. Here I'm saying schema is enabled, so that means it knows I need to handle with the schema. And I says key need to convert from Confluent Connect Avro converter, and this is my schema registry URL, right? This is my Docker URL because in my Docker Compose file I gave the name as a schema registry, right? And then I need to say value is a value schema enabled true, and then also I need to tell where the value schema register is. You can have two different schema register for the keys and values, doesn't matter. And then I need to tell what is the converter for the value. So you can have a different algorithm to convert key, different for value, different schema register key, different schema register value. It doesn't matter. Okay. So now, and I don't need this property because it's already was there. So now you need to understand these two classes, IO Confluent Connect Avro Converter and this one, right? So to get this class only, we get a separate Docker file. Why? As I explained, Debezium stopped officially native support for this Confluent schema registry, right? So now I'm going to, I hope I didn't make any mistake. Okay, so now my connector will start. Yes, connector is restarting. So now I can go and create other record here. Crash 2, Colombo 2. Let's see. So it picked my record, and let's go to Kafka and see. Yeah, now I got new record. So now you can see here. So this one, right? This one carrying the all the schema. This is the first record, right? But the second record, it doesn't have any schema information, right? But I can convert this to Avro and decode the message. It just have the payload, right? And oops, yeah, this because the first message is not with the schema register, so it like kind of a stuck to convert this. So what I'm going to do is I'm going to delete the topic. It's going to create again with a new message. I'm not going to sing from the beginning, right? It's but I can do it if I want, but I'm not going to do it right now. So here I'm going to create other record. Krish Dinesh, Colombo 3, let's say Sri Lanka, right? So now I create other record, and it's supposed to sync. And if I go here, I should see the topic. Now I can see the topic, right? So I see the one message, right? So now you can see I can see this message. I need to connect to Avro, and oops, again I think I made a small mistake on configuration. Let's see why. So probably I made some error on this one. Here I need to tell Kafdrop where the schema registry is. So I think I missed that part. After this Kafka Broker Connect, I need to add the property tell where the schema registry is, not only to this one, and I need to tell it here also. I need to tell here in the Debezium connector. I'm going to use it here. I need to tell what is the key converter and what is the value converter and what is the schema registry URL. So same properties we put in the connector, I need to put it here as well. Right, so that is the reason it cannot, it didn't work. So hopefully now it should work. So now everything seems up. Oh, it's not up yet. Okay, now it's up, and Kafdrop, that's also up, right? I don't think it will be able to decode this message. Oh, it decoded it did well, right? So now it works. So now you can see before is null, after is this one, right? But let me to show you something. I'm going to update this record, right? I'm going to update where. So what is the ID of this record? ID is 3. Okay, ID equal 3. So now once I update this record, I'm supposed to see other message here, right? So now you can see still before is null. Operation is update, but before is null, because in Postgres, so by default it doesn't emit this before event. For that you need to enable this replica identity for my table. So now I updated it. So I'm going to add again saying Colombo 7 here, and I'm running again. It's updated. Now I should see the third message. So now you can see third message, before is Colombo, after is Colombo 7. So now I can see the before and after, right? So now, so you can see everything is fine. I can get the message up to here. So now if you go to our schema registry, so if you see subjects, right? I think subject is the simple. So you can see what are available in my schema registry. So now I can go here. Sorry, I can go here, versions, latest, right? Oops, sorry, small mistake. So now you can see my schema is now available in the schema registry, right? So that is why my message doesn't carry the schema, right? That's why my message doesn't carry the schema. So now we are good. So now we can get the source data here. Now we need to see how we can push this data to our next database, right? For that one, I'm going to use a MySQL database. For that database, I already created, because since I show you how to create one database, I just created this database myself. Right, so now here if I go schema, you don't see any databases here, right? So I'm going to create database. I'm going to create as a employees DB, right? Just enough for me. So now what I'm going to do is I'm going to create my sync connector here, right? It's the same way what we did, what we first created was a source connector. So now we are going to create a sync connector. So this is a JDBC sync connector. So this is my code. I'm going to share this all the codes on my GitHub. So this is what it says. This is my database information. What is my destination database username and password? Again, don't use admin accounts when you're syncing to your destination. And then you are saying table. So here this is very important. Delete enable true. If you don't set this explicitly, by default it's false. So that means insert update event will be captured, but delete event won't sync into your destination database. So it won't delete the record from the destination database, right? So when you set the set to true, you must set the primary key is to record key, because you must have a primary key, right? So since I remembered that, let's go and see whether our database has a primary key. Yeah, it has a primary key, so we are safe, right? And then we have a key converter settings, like we know this now. So this is a schema euro encoded message, so it need to tell where the schema registry, how it can decode the message and everything. So this is that information, right? So everything look good. I'm going to create this connector. So now it will create it here. So look good, we have two connectors and it looks like it's synced. So let's go here and see our employees DB. In the tables, you can see employees table, right? So now I'm going to write a query, select asterisk from this one. Oops, it says okay, so use employee DB employees DB. Okay, so select asterisk from employees. So now you can see we have our employee, right? So Krish Dinesh, Colombo 7, right? So let's go and update this record, right? Colombo 7, Sri Lanka. Okay, I'm going to update this record. Okay, it's updated. Now ideally it should come here in a while. See, it immediately came here, right? So let's insert other record. I'm going to create other record, let's say just a Krish, right? And you can see that record also came, right? So let's create other record, Nairobi, and then again run. So in the destination database, you see, destination database, you see, right, it's coming, right? You can see it's perfectly working. So now let's update Nairobi's record. The ID is 5, right? Let's say I'm going to say Nairobi is in Gampaha, right? So I'm going to run this record, and right, you can see it's updated. Now everything worked smoothly, right? So now let's see the delete, right? So I'm going to delete number 4, delete from where ID equal 4, right? So that record is now deleted from here. Select asterisk from. So now yeah, 4 is deleted, 1 2 3 5, right? 4 is deleted. So now you have a 2 4 5, sorry, 3 4 5, right? Oops, 4 is deleted. So now create, update, delete, everything is perfectly working, syncing from your source database through Kafka and to your destination, right? So if you go here, go to Kafka, you can see all these messages in Kafka, right? So for the delete, okay, this is important. Okay, it's good that we came here. So you can see so delete is this one, right? So the operation is delete, right? So this is empty record. So this is called tombstone record. So this is the usual way how the message transmission work. When you delete it, it sends the tombstone record after that to say this is the end of delete, or kind of filling that gap. And you can go and read about tombstone records. So it's a really, there are really nice good articles on the internet, right? So you can see here it's a delete, and then before one was update, right? Operation is update. You can see before record is 5 Nairobi Sri Lanka, the after record is 5 Nairobi Gampaha, right? So now we demonstrate everything. So now next most important $1 million question is how we can make sure this is up and running. Yeah, it's a very important question, because now you have a source database, you have a connectors and connect to destination database. In case this Debezium stop, in case Kafka stop, in case something is stopped, then your destination data won't sync. So you may connected some report, some other application to your destination database, but you don't know its sync is stopped. So you are reading technically old data by thinking these are new data. So many things can go wrong. So therefore, checking the health of these connectors is very important. So how you can do it, I explained before. Kafka Connect is Debezium is just a connector, is with the engine with the REST APIs. So you have REST APIs, we can use those REST APIs to see the status. First we can get what are the connectors available. So you can go to these connectors, right? So you have 2 connectors, right? So what I'm going to do is I'm going to check one connector here, and when I connect that, so it tells me about that connector information, right? So my connector configurations and everything. So then I can say status, and then it tells whether connector is running or not, what are the tasks is running. Even you can restart this connector, right? So how you can restart? To restart, you need to send a post request, right? So you can create a post request to the same main point with restart, right? So now it's being restart. We can see exactly, because it's very quick. So it's restart. I mean, I can assume. So now let's do something like this. So I'm going to check the status. I'm going to post this connector, right? What is the connector we are referring here? PG connector. So PG connector, I'm going to post this. I'm going to go here, post this connector. Right now connector is paused. Now it says running. If I check this now, it says paused. right? So if the connector fail for something, it says fail. But I can think of somehow how I can forcefully fail this. So now, in case if the connector is fail, it will show you here as a fail, right? So now we saw how to set up this, and we saw how to configure this to sync, and also we saw how to do the maintenance. It's good you have some sort of a service, keep monitoring your connectors and then check the connector status. For example, if you go with the next connector, and we can see it here. So if you go with the sync connector, I just need to put it here, and then if I get that, I get all the information, right? Keep in mind this return all the information about the connector including password, right? So and then if you say status, and then it will show you the status, right? So now this is how you can configure and maintenance work. It's up to you how you do this. So now we did a long tutorial and we learned so many things, right? We learned how to set up Kafka, how to set up Postgres, and how to configure those, how to set up a Debezium, how to configure source connectors, how to configure sync connectors, how to sync data from source to destination, and also how to maintain those, how to make sure connectors running, how to check health endpoints, and how to restart in case of failures. We learned so many things. So now we can do this perfect, production ready, enterprise level CDC configuration by looking at this tutorial. I think I feel huge gap we had on YouTube and all other free platforms. So now anyone can refer this. So please share this video to your friends and who's interested on this, so then they can get a benefit of that. And also make sure you comment your ideas about this tutorial, so it helped me to do the next tutorial. Then until I see you again, stay safe, take care.